Alright, man. We're headed to the land of arcs and sparks. I have a lesson in tough love for you. Hang on. And here we are, once again, at the bench with our new friend Al. What's going on, Al? Long time no see, man. Drop on by some. Yeah, no, don't. Noob Tech 101. This is a tough lesson in love. Don't burn your house down. Don't set your bench on fire. Don't set yourself on fire. Don't get fired from your job for setting your meter on fire. Having had my hand in causing the sudden unemployment of a fellow technician in a biomed shop whilst he was still in his 90-day probationary period, I felt we should talk about how not to set things on fire. Now, this is a story of 2 meters. One, my fluke. The other, I think it was $16 China Crap Special, which, by the way, is my favorite meter. The Fluke is far better at checking electrolytic caps if you're so inclined. But before we talk about any of that, let's talk about my logic probe that I had to build while a college student, a young lad in college. I had to build the probe to take my digital electronics courses, which seems kind of like the horse and a buggy swapped ends, but right on. And so this is a talk about current. When you're about to check current with a meter, I'm not going to tell you how to check current with a meter right now, but I will suggest this. In a series circuit, the same current flows through all of those devices. The same current will flow through the resistor R1, through the light bulb, then through your entertainment device, through your movie maker, your 7300. And then if we cut the wire, you insert your meter in series with the rest of the devices. The same current will flow through the meter, and you can measure it. Now, if we were going to mock this circuit up, ideally we would pass 90 volts through said movie maker device. Maybe, 45 amps in receive mode. And get the marshmallows out and have us a bonfire. Okay, we got that out of the way. When you're using a meter to check current, it will be placed in series with the device you're measuring the current flow through. Okay, that's a given. When you're done using your meter, always, always, always. Did I mention that you always do that? You always do that, and don't forget you always, when you're done measuring your current, you will always do that. Or move your positive probe connector back to the volt ohm position. Okay? Because if you don't do that, you will. I've done it a handful of times in my life. I'm being honest with you, man. I have. We all will. But it can become a problem. Okay? So I'm going to pause this because I want to reconnect those and ask you a question. Okay, and I know this is pretty shaky because it's a handheld video by design. Okay? It's an impromptu because I feels it, man. I feels it. It's very important. you can get hurt. You can get burned. You can set things on fire. I'm telling you. Because this is a story of two DMMs. Both of them are fused. They're both marked 10 amps. Both of them can measure up to 20 amps for a certain period of time, and it's specified in the specs. They both have 10 amp fuses in them. Okay, now then, these are heavy duty probes that I use for measuring current. I bought them specifically for their current handling capability. They're plugged into the amp jack marked 10 amps. Okay. This meter, on the other hand, has the same fused current input, has the same capability as the Fluke, but look at look at these, that's ultra thin wire, which is great. And this is usually why I use this meter, just because they're flexible. And I'm usually measuring something silly like a resistor or something. Okay. Now then, both DMMs have a 10 amp fuse. And the internal construction of this meter actually is pretty good. I was actually pretty impressed. And I realized if you use that meter improperly, you can have a problem. And the problem's not going to be inside of either of these meters. Well, in one case it is, in one case it isn't. When you leave your probes connected like that and you forget, and you grab your meter, you decide, hey, I'm going to check my car battery voltage. You carry that meter out, slap those probes across your car battery. I want to ask you a question. On this meter, where's the fuse? Inside, snapped into a connector on the board, you think? You're right, it is. When you carry your happy little Fluke out with the meter leads connected as such and slap it across your car battery, that fuse is going to blow. The meter will be fine. These probe leads will handle that 20 amp pulse of current just fine. Fuse will blow. You'll say, oh crap. Better not do that again. In this meter, where's the fuse? You think inside? Not anymore. Not with those probe leads connected. You know what? I'm holding the fuse right now. If I hold these wires and connect that to my car battery, you know what's going to happen? I'm getting burned. In the biomed shop, that's exactly what we'll call him Joe, because that was his first name. That's exactly what he did, and he had those meter leads curled up on a piece of paper, and he set fire to both the leads and the paper. And there's a biomed story of truth, and a plea to be careful when measuring current. Understand where the real fuse is. Bye-bye, 7300 movie maker. Bye-bye. I hope you're well. Take care.